Okay, so let's just go through. Let's just go through and prep for the test. Again, it may take us more than one day. Test won't be till Friday. Try to be like really. I mean, be brave. Volunteer some. Try to contribute. Your goal should be to make at least one contribution per day when we're doing stuff like this. So identify the parts of the expression. Raise hands here. What's the variable, everybody? What do you think? What's the variable? Yes, sir.
Me?
Yes.
Y.
It is y. Excellent. What is the coefficient? Yes. -5. Outstanding. What is the constant? Yes. 10. Outstanding. Okay? Give me thumbs. We good? Just vocab stuff, right? Just vocab stuff. When you're studying vocab, it's really low level. A good way to do it is, something else I want to mention. Before we dive too deeply into this. We talked about sleep, right? About the importance of sleep. Okay, I want to tell you something else here because this is so critical. I wanted to spend a couple minutes on this. We'll just do it today. How do you learn effectively? Like when you guys study, I think 90% of the time you're probably doing things that are highly ineffective when you study. Really. So I want to help you be effective. Studying by reading material and just reading it and rereading it is worth almost nothing. It does you very, very little good. If you look at some studies, and these are repeated many, many times, fairly recent stuff though, when you look at this research of educational research and brain research, people, here's an example of one. They took a group of people and they taught them some material, and one group was tested on it the next day, and then all they got to do was see answers to the test and look at the answers to the test and see where they made mistakes. Another group was allowed to study the material 5 times over the course of a month, including the day before the final test, which was a month later. First group, but they weren't tested the whole time. They were just studying it. When they compared the results, again, first group studied the material once, they learned it, and then they had a chance to take a test over it, got results, waited a month with no additional studying. The other group saw the material, they were able to go back and study the material on 5 different occasions, including the night before the test a month later. Which group did better? And it wasn't even close. The first group that saw the material, studied it once, was tested over it, and saw the results, they did far better than the group that was able to study 5 times but never were tested on the material. What's the moral of the story? The only way to effectively learn material is to test yourself frequently. That's it. Just reading it or looking at it does almost nothing. That's very passive. Learning is a highly active activity. Right? When you learn something, you really have to be intensely involved in it, but you can't do it for long periods of time. The best way to study is to go really hard in the paint for a short period of time and then go away from it. But that's the only way to really do it. When you're studying, you should not have the TV on. You shouldn't have. You got to be in a place where you can just really concentrate, but do it for a short period of time, and that pays huge dividends. Spending 5 hours doing kind of crappy studying that's passive is almost worthless. A half an hour of intense studying is very effective. Okay, so the way to do this is frequently test yourself, and then make adjustments based on the results of the tests. So I would argue you guys do this every time you do an assignment. Now, with this current format, you're testing yourself, right? So if you use this properly, this is really all it takes. When you do an assignment, you're testing yourself. How come? Like you're doing a math assignment. You've had some experience with this. Every time you do it, you're testing yourself because you have to get the right answer, don't you? So you know right away if it's right or wrong. If it's right, great, you know it. If it's wrong, that tells you, okay, I've got to fix something. And you do it early in the process so you can make adjustments and reinforce the actual learning, right? So the way this is built, I think you get that all the time. But just sitting there reading stuff or looking through notes on its own has little or no value, right? That stuff is useful when you're trying to use it to answer questions, right? But beyond that, it's really not very useful. The other thing that tells you is when you're doing your work, it's really important to jump on it early and then get back to it later, right? Don't procrastinate. If I go through something in class, can't wait 3 days to do the assignment. You want to do it as quickly as possible, at least parts of it, at least some of it, so your brain is able to deal with the information and organize it, connect it to prior learning. If you do that within the first day, it's highly effective. After that, the effectiveness starts to drop off a little bit, right? Now, you can always go back and look at a video and then do it right after the video also, right, on YouTube. But that's really key. You got to test yourself, okay? Questions on that? Okay, and I tell you what, you can save a lot of time and energy if you just do that. Just focus hard, study hard. But how much time are you guys spending on homework at home? I bet you, if I look, I don't think you have to spend very much. People that are doing well on the homework, when I look at it, typically it's not very much time. If it's too much time, let me know and I will make an adjustment. But I think if you averaged 15 or 20 minutes a day of just concerted, focused effort, that is more than enough, right? It might be half an hour one day and none the next day, but I really think that's plenty. Okay, write the expression as an algebraic expression. Use the variable x to represent the unknown number. Okay, so let's just go through a few of these. Twice the sum of a number and 8. Think about that for a second. Talk it over. Twice the sum of a number and 8. We can kind of break this into parts maybe, but talk it over. Can anybody tell me what does twice mean? Okay, 2 times or times 2, right? So that's giving us 2 times. And then how would I say the sum of a number and 8? X plus 8. Okay, so if I'm doing twice that whole sum, I need to have parentheses, don't I? Everybody agree? Okay, give me thumbs on that. Does that make sense? Okay, good. All right. Was that? Okay, that's the only one for that. So let's do a quick review here. Subsets of real numbers. Okay, there's really only 4 of them I want you to know. The other ones you'll just get. You'll just get by using the names, without even thinking about it. They'll just come to you with time. Real numbers, all numbers you've ever used. That's it, right? Real numbers is everything. Rational numbers and irrational numbers are the 2 subsets of real numbers. All real numbers are either rational numbers or irrational numbers. So one way we could define real numbers is every point on a number line, or all numbers. The other way we could define the set of real numbers is all rational numbers and irrational numbers. Okay? It combines both of those. What are rational numbers? What do we say about what does ratio mean? Starts with an F. Fraction. Ratio means fraction, right? Ratio and fraction are the same thing. So rational numbers are fractional numbers. Can anybody remember how we say this? How we say that statement? We've got set brackets, right? So we'd say the set of all that, right? The set of all A over B such that A and B are integers, and B can't be 0 because you can't divide by 0. So that's just a mathematical way of saying all numbers that are fractions can be written as fractions, right? You can write them as a fraction of integers. What are irrational numbers? Numbers that can't be written as fractions, okay? They're real numbers that are not rational numbers, all the other real numbers that can't be written as fractions, okay? And then the other one is integers. What are integers? Well, they're just positive and negative whole numbers, right? They're all the dash marks on a number line, right? That's the set of integers that goes forever. Okay, give me thumbs on that. Is that all? I mean, you guys have worked with this. I'm sure that's fine. Just wanted to review that real quick. Here's another look at it right there. Real numbers are everything. Irrational numbers, numbers that aren't fractions. Rational numbers, numbers that are fractions. Remember, as decimals, rational numbers do what? If we make a rational number into a decimal, like 1/2 or 1/3, what do they always do? 2 things. Terminate, like 1/2 is 0.5, done. Or repeat, like 1/3 is 0.3 repeating. Irrational numbers like pi never terminate and never repeat. They just go on randomly as decimals. Okay, that's not going to be on the test, but just you need to know that at some point. Okay, how about this? Uh, so what is this set right here? Vote with your fingers. 1, 2, A for 1, B for 2, 3 for C. So is it 1 through 6? Which one is that? That set right there. So remember, the dot, dot, dot means it just goes forever in the negative direction, forever in the positive direction, following that pattern. What is that? Yeah, that's the set of integers, isn't it? And if you're rusty on these, well, you just make some flashcards. And the other thing when you're trying to memorize stuff is when you're trying to actively try to memorize it, what really helps is just to write it down and then check yourself, crumple that paper up, write all the stuff down again, crumple it up, and just check yourself. I mean, 2 or 3 times doing that and you have it all down. Yes? Natural numbers, that will not be on the test. Natural numbers would just be the counting numbers. It's starting at 1 and going up, right? So real quick, I mean, I'll just show them to you, but you don't need to know them. You don't need to know them. Those are the natural numbers. They start at 1 and just count up by 1. The whole numbers start at 0 and just count up by 1. I'm not going to test you on those, though. I mean, I could, and it's not that they're hard, but I just don't want to give you too much stuff. Okay? How about this one? How would I say this again? So what's the blue part? The set of all x, good. What's that bar mean? Such that, and then all the rest of this. X is rational or x is irrational. So all rational and irrational would be what? Vote with your fingers. 1. Yep, that's the set of all real numbers. Good. Okay, let's simplify the expression. Okay, when we're simplifying, just remember, and what should you always write down on your work? Because your work is going to get graded. We'll talk about that when we do the test. But what you're going to do, talk about it more, what you're going to do when you take the test, it's going to be online. So it's going to be the same kinds of questions that are on the review. They'll look very similar, look very familiar. On a piece of paper, you're going to write down the number of the problem and the work next to that. You're going to take a picture of that and you're going to submit it in Google Classroom. And I am going to use that to assign partial credit, which is very important for you. The other thing it does is when I grade it, I will give you feedback, detailed feedback, including links to videos, parts of my instructional videos that exactly talk about something that you missed. So if you want to do a retake, it makes it easier to prep for a retake. Okay? But one of the things you could do that would earn you some partial credit on a problem like this would be to write what down, as soon as you see the word simplify, what would you probably write down on your paper? PEMDAS. You'd write that down, wouldn't you? You'd write down the PEMDAS ladder with a downward arrow for simplifying, which is starting at the top and walking down the ladder from the top, right? Okay, so let's go through the steps. Simplifying this, what would we do first? What? Parentheses, you bet. Parentheses goes first, right? So we've got this. What is 10 minus 12? Negative 2. So all that stuff becomes a negative 2. That's the first step. What's next? Exponent, yeah. Okay, what is negative 2 to the 4th? What's it mean to take something to the 4th power? Times it by itself. So you've got 4 of those multiplied together, right? So negative 2 times negative 2 is 4, right? Times negative 2 is negative 8. Times negative 8 times negative 2 is positive 16. And we always know that a negative number to an even power is always going to be positive, right? Negative number to an odd power is negative, yeah. So then we do exponents. Okay, that's next. Exponents would be all this stuff, and that just gave us 16. And then what's the last thing we do? Multiply. You got this, right? Then we multiply, and all that is just equal 4 times 16 is just 64, and we're done. Okay, give me thumbs. How we doing? All right, good. Okay, how about this one? A little more complicated. Where do we start with this one? When we say parentheses, which parentheses are we talking about? Inside ones. Good. We start from the inside. Okay, so first step would be, parentheses, and we're going to deal with these. And what do we get from those? 6 minus 5 is negative 1 plus 7 minus 17, negative 10. Okay? And those are what's inside the brackets. Now what? Oh, there we go. Okay, so now the next layer out would be brackets. What's negative? Well, that's supposed to be positive 1, right? Not negative 1. Whoops. Positive 1. What's 1 plus negative 10? Negative 9. Okay. And now we just have to do 5 minus negative 9. Last step. Last step would just be addition, right? Okay, what are we, adding a negative is the same as, or subtracting a negative, sorry, I gave it away. Adding, there you go. So 5 minus negative 9 is equal to 5 plus 9, which is 14. Okay, give me thumbs. All right, good. Yeah, let's do that one. Okay, what about this guy? I've got a big fraction, top and bottom. When I have a big fraction like this with stuff on the top and stuff on the bottom, how do I organize it? I break it up. I do everything on top separate from everything on the bottom, right? So on the top, what would I do first? Multiply or subtract? Multiply. Sure, so on the top, if I take this stuff, what is 1/2 times 4? 2. On the bottom, do I add or multiply first? Multiply. What is 1/3 times 9? 3. Whoops. Gosh, I got the wrong color. Okay, so now only one thing left to do on the top. I subtract. What is 2 minus 5? Negative 3 divided by, on the bottom, 7. And that's my answer, negative 3/7. Okay, good? All right. Evaluate the expression when x is 9 and y is equal to negative 3. So we got it. Here's an important word, very important word. What does evaluate mean? Remember, value means number. So what does evaluate mean? What am I doing when I'm evaluating something? I'm plugging in chugging. I'm plugging in values and then simplifying. That's it, right? Plugging in numbers and then I simplify what I get. So I'm just going to plug in these values, okay? So what's this going to give me then? On the top, I'm going to get 3 plus 2 times my absolute value. And every time I plug in a value, put it in parentheses just to be safe, right? So I'm going to plug in my value of x, which is 9, minus my value of y, which is negative 3 in parentheses. On the bottom, I get my value of x plus 2 times my value of y. So that's 9 plus 2 times negative 3. Do you see the importance of those parentheses? Right? When you're subtracting a negative, you really need them, don't you? Okay, so then on the top, that gives me 3 plus 2 times the absolute value of what? What's 9 minus negative 3? 12. Yep. On the bottom, it gives me 9 plus 2 times negative 3 is negative 6, right? Okay, we're getting there. And when you're writing this out, one thing I see with people, as I've helped people on this, is they try to do this without writing out each step, and it causes problems. It seems like a shortcut because it's less writing, but it ends up causing lots of problems. You have to keep redoing the problem. If you just write out each step where you're plugging in stuff and simplifying, you're going to get the right answer, especially on a test. That's important. Okay, so we'll keep going. On the top, what is the absolute value of 12? 12. What's 2 times 12? 24. So on the top, we're getting 3 plus 24. On the bottom, what's 9 plus negative 6? Positive 3. So we get 27 over 3, which is what? 9. Okay, good? Good, good? Okay, I took up a lot of time today, so we'll see if we need to. I'm willing. I think it was important stuff to talk about, so I'm willing to push the test off even to next week if we need to. We'll review tomorrow and we'll see how much time, because I want you to have a little bit of time to work in class on this stuff too. Okay, so we'll see how it goes. Okay, so wrapping things up. So real quick, I think what we're going to do, the plan here is going to be we'll finish going through the review today in class. Tomorrow will be mostly a work day. I want to get you guys set up. Everybody needs to make sure that you have a Google Classroom app on your phone, because we want to set you up to be able to download your pictures for all the tests. You're going to take pictures of your work on the test and submit those in an assignment on Google Classroom. So tonight, if you need parents' permission to install apps on your phone, to do 2 things tonight. Make sure that you log in, so log out of if you're in some other Google account, log out, log in with your school account, download and install Google Classroom so you can access it from your phone. Okay, do that tonight if you need parent permission. And then tomorrow I'll kind of explain and you'll practice uploading a picture. Questions on that? So test be Monday. Test be Monday, yeah. And I'll give you tomorrow. It gives you the weekend then to kind of do a little bit of extra preparation. Tomorrow will be a day to just wrap up review, get questions answered after doing the thing at the beginning. Okay, sound good? Okay, so here we go. Let's real quick. Let's zip through this stuff. Maybe even get a little work time today, hopefully. So what's the opposite of negative 9/10? 9/10. What's the reciprocal of negative 9/10? Negative 10/9, right? When we flip the fraction, the sign stays the same. It doesn't change. It stays negative. Good. Okay, quick review of properties of real numbers, right? You got to know all these properties. So remember, we have properties for addition and multiplication for all these, except distributive, which is just a single property, but you guys know that one. For all the other ones, like look at the commutative property. Remember, to commute means to exchange. So the commutative property just says A plus B is the same as B plus A. I can interchange the positions of 2 things that are being added or multiplied, okay? Associative property just says if I'm adding or multiplying more than 2 things, the order in which I group those things to add or multiply doesn't matter. I can group them in any order I want to when I add or multiply more than 2 things. Distributive property, you know. The identity property is all about keeping the identity of what you start with the same, right? So how would I end up with the same number that I start with? But when I add something, I'm going to add 0, right? Any number plus 0 equals itself. That's the identity property of addition. For multiplication, how could I end up with the same thing I started with? Well, I multiply by 1, right? That's the multiplicative identity, is the number 1. So any number times 1 is equal to itself. The inverse properties kind of go with the identity properties. Whatever the thing that I'm adding or multiplying by a number to keep it the same, now we want to know what could I do to get that as an answer. So if I start with a number, how do I get 0? I add its opposite. So A plus negative A equals 0. The 0 is important because that shows up in the identity property. How could I multiply 2 things and get 1? I multiply a number by its reciprocal, okay, to get 1. So again, those are the inverse properties. Inverse property of addition, A plus its opposite negative A equals 0. Inverse property of multiplication, A times its reciprocal, 1 over A, equals 1. Okay, give me thumbs on those. You guys have used those a little bit. It's just memorization. I mean, those you just have to memorize. Let's practice a little bit. Okay, you guys think about these and I want you to raise hands. Everybody try to contribute at least one item today. That's your goal. So what about the first one? Okay, identity property of multiplication. Okay, next one, what's that? Commutative property of multiplication. There you go. Okay, this one's a little trickier. 6x times 1 over 6x equals 1, and that's the part that gives it away. What's that? Inverse property of multiplication. There you go. Good. And it's easy to mix those up, inverse and identity. Those are the ones that I think are the trickiest. Okay, what about this one? Yeah, that's got to be the associative property because I'm just regrouping stuff, right? So it's the associative property of addition. There you go. Okay, good, good. How about that? 9 plus z equals z plus 9. Commutative property of addition. And then what's that? We all know that one. What's that one? Distributive property. 0 plus 9 equals 9. Ah, good. Identity property of addition. Very good. How about this guy? Associative property of multiplication. There you go. And then finally, 8 plus negative 8 equals 0. Inverse property of addition. Great. All right. Love it. Okay, it's just a little more practice writing mathematical sentences, right? How would I say this? Twice x plus 5 is the same as negative 7. 2x plus 5 equals negative 7. Good. The quotient of n and 3 is 5 times n. Well, how do I say the quotient of n and 3? n over 3 equals 5n. Good. Remember, quotient means division, right? Difference means subtraction. Quotient means division. How about this one? The product of 8 and x is less than or equal to negative 14. 8x is less than or equal to, so that's that symbol, right? Negative 14. Good. Okay. And last one, twice, this is the trickiest one, twice the difference of x and 6 is negative 22. Ah, good, good. 2 times the quantity, x minus 6, equals negative 22. Very good. Okay, give me thumbs on that. How we doing? Give me thumbs on there, everybody. Up, down, sideways. Where are we on this stuff? Okay. All right, simplify the expression. So first thing you're going to write down, remember you're going to be providing me work on the test, right? And we talked about that a little bit yesterday, right? About the importance of that. Yeah. So that's where you get your partial credit. First thing you would write down if you're seeing simplify is PEMDAS with a downward arrow because we're climbing down the PEMDAS ladder from the top when we simplify, right? Okay, so what would we do first here? You want to go inside the parentheses. Okay, inside the parentheses, let's see if we can do anything. Can I combine 5 minus 3c? Okay, so we can skip through that one, right? There really is no, we had to try it, but there's nothing to do with parentheses. Are there any exponents? No. What's the first thing we hit? Ah, okay, good. Multiplication, which is distributing. So I'm going to distribute the negative, and what's that give me? Plus 3c. Good. When I distribute the negative to the negative 3c, it makes it a plus, doesn't it? Subtracting a negative is adding. And then finally, last thing we would do here is just add and subtract. And if we combine like terms, what do we get? Negative 9c plus 3c is negative 6c, right? And then minus 5, and that's as far as we can go, right? Everybody agree? Okay, same thing down here. Again, inside the exponents, can I combine those? Nope. I have an exponent, but there's nothing I can do with it, right? I'm just, y squared is y squared. So the first thing I would do here is what? Distribute. Yeah, I'm just going to distribute the negative 3, which gives me negative 3 yz minus 6. Good. And then I've got all these other terms. Next thing would be what? Combine like terms. So let's see, what do we got? I've got some yz terms to combine. And anything else? Yeah, I've got some numbers to combine, some constants. So how many yz's do I get? Negative 3yz minus 5yc is negative 8 yz. What do my numbers combine to? Negative 5, so minus 5. And then what was left over? It looks like there was a plus y squared that doesn't combine with anything. It just stays the same. Good? Give me thumbs. How we doing? Ooh, I think period 1 is going to be all over this test. I really believe it. So now solve the equation. This is a little different, right? Solving, we've got two things to do. We've got to simplify until we can point to a single variable, which we can't do yet, and then we flip around and isolate, right? Because everybody agrees there are multiple y's in that thing. I can't isolate y yet. So what do I do first to simplify? Distribute. Yeah, good. So we're going to distribute the 2. We're going to distribute, what do I distribute here? Negative 2. Good, so I'm distributing that whole thing. And that gives me, what, 5y, what? Plus 2y minus 8 equals 7y minus 2y plus 20. Good. Good. Common mistake is to get that sign wrong. Remember, if you're distributing a negative, it's going to flip the sign of the constant too. So now we just combine like terms, right? On the left side, I could combine those guys. 5y plus 2y just gives me 7y, and then I have a minus 8. Over here, I could combine those. 7y minus 2y is 5y plus 20. We're getting there. What's the last step before I can isolate? What do I need to do? Okay, I got to push the y's to either the left or the right, by adding or subtracting. Which way do I want to push them? Left, so I get a positive number of y's. So I'm just going to subtract 5y from both sides, which cancels those guys, right? And we end up with 5y, or 7y minus 5y. Everybody agree that's 2y minus 8 equals 20? Okay, at last, can I point to a single y? I can. So now I get to isolate, right? There's my y. What are the two steps in order to isolate that y? What do we do first? First we add 8. So I get 2y equals 28. Last step? Divide by 2 to get the y by itself, and we get our answer. Y equals 28 divided by 2 is 14. Good stuff. Okay, we're solving the equation here. Same kind of thing, right? I'm going to have to distribute first. Everybody agree? Yep. Okay. So I distribute. Okay, I should, let's, got a little too much chit chat here on this review. I want to make sure everybody's able to really focus. We'll get through this in a hurry here. But left side, what can I do? Combine like terms. So I get 3x plus 22 equals 3x plus 3. Okay, does anybody anticipate what's going to happen here? We're going to get no solution, right? We can see that. And how come? Because what's going to happen? What's my next step going to do? Good. Okay, I'm going to try to push the x's to one side or the other, but no matter what I do, when I subtract 3x, the x's disappear, and I get the false statement 22 equals 3. That's false. So how do we interpret that? No solution. Good. Okay, what if the x's had gone away and I'd gotten a true statement? It would have been all real numbers, right? Okay. Question. Okay, so if when the variables go away, that's the math god's way of telling us it doesn't matter what the value of x is. The answer is going to be the same regardless of what x is. If it's a false statement, that's their way of saying it doesn't matter what x is. That's never true, so there are no solutions. If I had got something hypothetically, like what if I had gotten, oops, let me do this in green. If I had gotten something like this, 5 equals 5, which is true, it would have been like saying it doesn't matter what x is, that's always true, so every real number would work. Any possible number would work. It's always true. Does that help? Okay. Okay. Okay, fractions. How do we deal with an equation involving a bunch of fractions like this? The trick, what do we call that? Clearing the fractions. Okay, but what first step is I got to figure out what number to distribute. What's the number I'm going to distribute here and why? 35. Good. How come, Destiny? What's that's the greatest common multiple, the least common multiple of the denominators, which is the same thing as the greatest common factor, right? Or sorry, the least common denominator, not greatest common factor. The common denominator is the least common multiple, okay? So you guys are used to saying finding the LCD for fractions, which in this case is 35, right? And that's the same thing as, that's also the least common multiple. Same thing. So that's what we're going to distribute, is 35. Now we got to distribute it to every term on both sides. What's my trick? My great trick. What's my great trick? When I distribute the 35, rather than multiplying and then reducing, what can we do here to make things a little easier? Yeah, cancel first. 35 over 7 reduces to 5, which we multiply by the top, right? So that just gives us 5 times x is 5x. 35 divided by 5 is 7, plus, or times the top, gives me 7x. And on the other side, 35 divided by 7, you already told me, is 5, times 9 is 45. There we go. Okay, and then so when we combine like terms here, 5x plus 7x is 12x, and that equals 45. Last step, divide by 12. Good. And we end up with x equals, and 45 divided by 12 is my answer. Can I reduce that? Yeah, what can I divide both top and bottom by? 3. Yeah. 45 divided by 3 is 15. 12 divided by 3 is 4. Okay, good. All right, now this, we solved an equation, so we can check this with Desmos. What would I do to check this? Say it again. Go ahead. Oh, okay, good. I'm going to plug it into the left side by setting the left side equal to f of x. The right side, I don't need to, it's already a number. I don't need to do anything to the right side. We already know what it's equal to, 9/7. So let's just show how this works. Let's remind ourselves how this works, because you can do this on the test and make sure you get it right. Okay, so we're going to say f of x f of x equals x over 7 plus x over 5, right? And then I'm just going to go down and do f of my solution, which is 15/4. And I'm going to turn that into a fraction. And what do you know? I get 9/7, which is what's on the right side. So it checks out, doesn't it? Everybody see how that checks our answer? I put that in the notes. Oh, wrong thing. Okay, give me thumbs on that. Does that make sense? Does the Desmos part make sense? Okay, do that. You'd be crazy not to. Write the following as an algebraic expression, then simplify. So we want to, for an expression, am I expecting an equal sign? No, it's not an equation, right? It's not an equation. So I don't get an equal sign. I'm just writing out an algebraic sentence using W, right? So what does the perimeter mean? The distance around the outside, exactly. So what am I adding up then? If I add up all four sides, what are they? I get a W plus 3 on the bottom. Let's go around in this direction. So then I get plus W. What about the top? W plus 3 plus the left side, W. That's the perimeter, right? That's my expression for the perimeter. Well, how many W's did I add up? 4. And then 3 plus 3 is? There it is. Okay? No big deal. Okay, now this is different. Use the diagram to find the angle measures of the triangle. Because I'm using the word find there, I'm solving something. I need to get solutions, right? It wants me to find the answers. So that's telling me that, yeah, I'm going to find numbers, so I'm setting up and solving an equation. Okay? First, I have to set the equation up. Well, what's the relationship that we're going to use here? It tells us the sum of the angle measures of a triangle is 180 degrees. So what's the equation I could set up then? Oh, okay, good. I'm going to add all those up, aren't I? Right? So we get x plus 4x plus x plus 6 must equal 180. There's my equation. That's a pretty easy thing to solve. I'm just going to simplify by combining like terms. X plus 4x plus x is 6x. Plus 6 equals 180. What are the two steps to solve for x? Everybody? What do I have to do first? I have to isolate. What do I do first? Subtract. Right? So I'm going to subtract 6, which is going to give me 6x equals what, 174? Last step. Divide by 6. And yeah, what is that? So 6 doesn't go into 1. 6 goes into 17 how many times? 2 times, with how many remaining? 4? 2 times 6 is 12. 5. 5 remaining, right? 6 goes into 17 twice with a remainder of 5. So I put the 5 up there, and 6 goes into 54 9 times. There you go. And you have a calculator, right? You can do all these on Desmos Scientific. So there's x. Am I done? No, now I need to plug those back in and find the lengths of the sides. Okay, so 29 is x. X plus 6 would just be 29 plus 6. What's that? 35. And then finally, 4x is 4 times 29. What's that? Well, what's 4 times 30? 120. It's 4 times 29 instead of 4 times 30. So I got to subtract away one of those 4s. 116. But again, you have a calculator, right? Okay, give me thumbs on that. Oh man, we're in good shape. We're in good shape. Okay. The perimeter of the triangle shown is 320 feet. Find the length of each side. Same kind of thing, isn't it? What am I going to do here? Again, I'm finding something. We'll go through this one a little quicker. So we have to set up and solve an equation. What's the equation I'm setting up here? Perimeter is? No, perimeter. Okay, the sum of all the sides, the distance around the outside. So isn't that just going to be 5x plus x plus 8x minus 2? And what's that equal to? Yes. So I'm just going to solve that, right? Combine like terms. 5x plus x is 6x plus 8x is 14x minus 2 equals 320. Everybody agree I'm going to add 2 first? And get 14x equals 322. And let's see, 14 goes into 322 how many times? I'll take your word for it. That seems right. 20, 32, let's see. I like that. Yep. 23 is what we get for x when we plug it in a calculator. So x is 23. 5x would be 5 times 23. What's that real quick? 5 times 23. What's 5 times 20? There you go. 100 plus 5 times 3 is 15, so we get 115. 8 times x minus 2. Well, 8 times 20 is 160, right? 8 times 3 is 24. So 184 minus 2 is 182. There you go. Very good. Okay, last one. Solve this equation for w. So we're trying to isolate the w. We can do that in one step. What do I do? There you go. Divide by LH, the things that are being multiplied. And I cancel both of those, and I got my answer. Look at that. Okay, good? Good, good. I'll tell you what I will do tomorrow. I'm going to give you an opportunity, if you want,